Alright, welcome to my fourth tutorial. And in this tutorial, what I'll be doing is bringing together all those techniques that we learned in the previous tutorials, right? So what we're gonna do now is apply that knowledge to like a real challenge, right? So when you open this notebook, just click on the link here. It'll take you to Zindi.Africa. Zindi is the African version of Kaggle. I think Zindi seized that opportunity that Kaggle opened by not catering to the African landscape with regards to machine learning and then data science challenges, right? So yeah, so when you get to their website, this is the interface that you'll face. Right here, you have all the competitions that are currently there. Here you would have all the list of data scientists that are registered on the platform. I encourage you to go and register if you don't already have an account. And then at the top right corner here, that's where you would see your profile. Let me click on my profile real quick. Right, so on competitions, it'll show you all the competitions that you have entered. Right. And the cool thing about Zindi is that every challenge that you get into, like every challenge that you make a submission for, you get 5 points for that, and then you will be ranked on the data scientists page. This page, Dr. Fayed is currently #1. He's been winning all the challenges, most of the challenges. So yeah, you would see based on the position that you were at the end of a particular challenge, you would get a score associated to you, but you have to be in the top 10, right? But like every challenge that you enter, you get 5 points, right? So now the challenge that we're going to be doing is the Standard Bank Zente credit scoring. Um, so before you get on the challenge, for me, what's important is you need to understand the backstory of the project, right? Of the problem, and you also need to understand like the data source, right? Like where's the data coming from? Um, what are my variable definitions and all that good stuff. So yeah, so when you get to it'll show you the format that you have to submit your results. The training data, it's where you use to train your model. The test data, you are going to take this test data, feed it through the model that you use to train with this data to get that format, and then you submit here, right? So yeah, let's go to the leaderboard. You'll see these are all the people that are on currently on the leaderboard. Now let's check my submissions. There's an earlier submission that I made that I got a 0.5 score, and I will explain how I got that score, which is a strange score because if you look at all the scores of the other entrants, it's a very um, long number. Okay, cool. So now let's go back to the tutorial. So that was Zindi in a nutshell. I encourage you to go there, create an account, and yeah, practice on this problem that I'm doing a tutorial on, and then later on, once you get more comfortable, you can pick other challenges that you like. By the way, the competitions here, they normally are for money. This one is for 2000 Zindi points. So at the end of this challenge, on the 2nd of December, whoever's on the top is gonna get let me check. So the top 10 submissions will on. Okay, so these 2000 points will be divided amongst the top 10 submissions. So but like normally the competitions that you get here, there's cash, there's knowledge challenges for you to get started on yeah, online comparative, data science challenges. Okay, these ones have ended already. Okay, cool. So let me take you through the content of the tutorial. So we're gonna start off with the imports, how I like to import my packages and why I'm importing those packages. The second step, you always do this, you have to do your exploratory data analysis. Like you need to ask your data questions. You need to be able to, get down to like, to know your data to that level. So when you're doing your EDAs, it also helps you understand the question, rather like the problem statement of the project, right? And then we're going to go down to feature selection. So we're going to look through the features that we have from the data in a training data set and also in a test data set. It's important that the ones that you select in your training data set also are available in your test data sets. Normally it's not the case. It's not always the case that they would match. Also in this case they will not match. There's one feature that we'll miss, but then we will have to create ourselves because the data is provided in a training set, right? So with all machine learning problems or challenges, you have to do benchmarking, right? So you need to understand what is the split of your credit defaulters and not, right? And then see if you can't just do random guessing. Like if random guessing doesn't work, then that would necessitate the need for a machine learning model. So you don't just start with the machine learning model. And so yeah, so the feature selection that we applied on the training data set, we will also apply on the test data set. It's important and imperative that um, all the data cleaning that you do on your training data set, you also do the same ones on your testing data set, right? So section number 6, then we're going to build the machine learning model. Um, and yeah, I mean, machine learning, okay, we'll see when we get to that section. And then the last section will have a bonus section where we talk about tips on how to improve the model that we just built here. All right, let's get down to it. So this is the first section. Your imports. I imported the usual suspects. You need NumPy, you need Pandas, you need Matplotlib, and yeah, you need scikit-learn. I did not use Pandas profiling. I used it in the previous iteration of this tutorial, but it'll make it long. And then I filter out my warnings because when I'm doing the data types transformations, I get like a bunch of warnings that make my notebook look untidy. And here, what I'm doing is I'm setting the background for all my visualizations, right? I want them to have this size and I want them to be on the white grid. And then the first section, I always do this. I've created this class. In the previous tutorials, we built functions and then you saw how you applied functions, right? So the analogy that I used last time was that a function is like your function is like a blender, right? And then your inputs would be your fruits, and then your outputs would be your smoothie, which is the what you want your function to return. So now what I built here, I put in all of my blenders inside a wrapper called data process. So what I'm going to be doing is I'm going to be calling this class data process and the function inside that data process. So it's nothing different from what I did from the previous tutorial. You can follow this or you can just erase the data process and then pull back all the data set back to um, this margin here. But I prefer to do it this way. I always do my problems like this, my data analysis. So the first function that I created, what I like to do is, because most of the data sets I get are too large for me to do diagnostics on, I split it into numerical values and categorical values. So what this function does is it will select all the integers and the floats from my data set, and then this one will select the objects, and then it will split it in two. And then what this one does is it plots a heat map of the entries where there are missing values so that I can be able to see and compare like which columns are worth savings and which one are not worth saving. And then df joiner, it just joins two data frames. These three here, I'll just use them to extract the month, the year, and the day from the column, right? I would have like a datetime variable, and I would just use this one to call out the day two to put in as a feature. What this one does, it plots like the correlation heat map of your data, right? So the first step, I read in my data sets, I downloaded those three files, my training data, my test data, and then my sample data, right? So now I'm just gonna call head off training data just to get feel of the data set that I have. Already you can see here there's a lot of nans, there's a lot of like missing values. Um, UGX, it's a constant value, and 256 were constant values, so they're not going to serve any purpose in trying to build a machine learning model, right? And then the batch ID and the subscription ID, there's other two files that you can actually use to get more data for these three. And then we have the transaction date. The customer ID is the one that you will get in your testing data to say for customer ID number 27, either they defaulted or not. And by the way, for the machine learning that we're trying to build here is a model that will take in data for a particular transaction and tell us whether this person is going to default or not. This is for an e-commerce traders, right? So they borrow money for various reasons, and then whether they pay or not determines whether they defaulted or not. So we're trying to take the data and then say for this particular user they're going to default before they default. Right, so the test data, we can see more or less similar, even though this one has different data and variables than that one. We'll get to that one below. And then this will be your sample, right? Your sample, like I said, you will take the transaction ID and say defaulted. You will always get this with Zindi challenges. Well, most of them, not all of them, but most of them, you will always get this guide to say that your submissions should be in this form. Right, so now you just want to check the data in the training data frame. We have 2100 rows of data, and we have 0 to 29, we have 27 columns, right? All of these are the columns that we have in the data. So now we're going to start with the exploratory data analysis. Like I said, I like to split my data into categorical variables and numerical variables. So that's what I'm doing there. And then now I'm just plotting the missing values. So now I can tell that issue date, loan, currency, loan ID, paid on date, basically all these ones here for my training data, the categorical variables, there's more data missing here than I can help. Say maybe if it was these parts, the yellow parts are the missing variables, I mean the missing entries. The purple ones is where there's actually an entry, right? So you can see from this plot that most of these variables here, we will need to drop them. And then with the numerical features, amount of the loan is final payback, is third party confirmed, is defaulted, right? This presents a bit of an issue because is defaulted is our y, this is our target variable, right? So we're going to be predicting for this. So yeah, for the purpose of this tutorial, what I decided to do was take my training data and drop all the missing values and then create a new data frame, right? And then from the new data frame, I plot the heat map for the missing values. Now you can see it's all purples. So remember we had 2100 rows there. Let's see, after dropping it, how many do we have, right? Let me just create that real quick. New df. So now we have 1400. So I think, yeah, about 40% of the data was lost when we dropped it. Also now this is the columns of the data frame that we have, right, after dropping the missing values. And right off the bat, is final payback, I wanted to check the values, right? And then I see it's 1 0. So it's when it's a final payment, it's a 1. When it's not a final payment, it's a 0. So that's a very useful indicator whether a person will default or not. So I chose that one. And I also let me just check out the product category, right? So this is the categories that people borrow money for. Number one is airtime, retail, data bundles, utility bills, and all that stuff. So, and also third party, it's a 1 or 0. So I'm gonna pick the third party one. I'm gonna pick is final payback, and I'm also gonna take the transaction date, the due date, and the value, like the amount that was borrowed. And then I'm gonna take that and then create my training data frame. So this is what I'm gonna use to train the data frame. Let me check out the data types. You can see this objects. So we need to convert these to datetime. I mentioned earlier that when I converted them to datetime, I get a lot of untidy warnings. So I imported my warnings and I filtered the warnings out. So we have floats here, 1 or zeros. They're enumerates, but anyways, it still works for this exercise. So what I'm doing right now is I'm converting this transaction date into a datetime variable. I'm converting the due date into a datetime variable. Now let's check on my date types. Right, so now you can see transaction date is a datetime variable. It was an object there. Due date, it was an object. Now it's a datetime. Let's check the head. Nothing has changed. It looks the same. It's just only the data types have changed for those. Right. So now that I've changed the data types, I can use this function that I wrote above to extract the month from the start date. So I'm going to create a new column, call it start month, and then extract the month from transaction start time, create a column called start year, extract the year from transaction start time, create a column called start day, and then extract the start date from there. The same thing with the due dates. I'm going to create a month called due month and then extract the month from this due date. So I'm just going to apply that real quick. Right, and now let's check my my new data frame. Right, you can see there's a start month, start year, start day, due month, due year, and due day, and new variables that I have. So now that I have this information represented in a different format, I mean this information I no longer need it, so I can drop these two. So this is what I'm doing here. Right, so now we have value is third party confirmed, is default, which is my target variable, and all these other ones. Right, so now I'm going to check my statistical analysis of all the numerical variables. For value, I can see the maximum value there is to 2.5 million. The count is 1.47 thousand plus that's a scientific notation, and you can see your standard deviation, your minimum value there. The same thing with this one. So maximum is it's 1, minimum it's 0 because it's 1 or 0. Same with this one, 1 or 0. Start month, its minimum is 1, max is 12. Start year, the same applies. Minimum is 2018, max is 2019, and then it repeats with the due dates, right? So what I'm going to do now, so that my model is able to train right on values that are on the same scale, right? Because we don't want the model to think that the start year and the due year and the values are the most important values only to determine whether a person defaults or not, because they are high values, right? So these ones are our zeros and ones, so we will not have, they would not have that impact in building that final model. So what we're going to do is we're going to divide the value by 5,000. The number is totally arbitrary. It's not really arbitrary. As the number that I saw was fit for this one, let me just divide everything by 5,000 in the value here. And then for the start month, I'm not going to divide by anything because it's between 1 and 12, right? It doesn't go that high. And then for the training years, I mean for the start year and the due year, I'm going to divide that by 100. And then for the days, because they go from 1 until 31, I'm going to divide them by 10. So it's going to be 0 0.1, 0.2, all the way to 3.1, right? So now everything is more or less on the same scale, right? You can see the values is 1. This would be a 5,000, right? Because I divided by 5,000. and is confirmed 0101. Start month, it's fine. I did not divide. This one I divided by 100, so it's 20.18, 20.19. The same with that one. Awesome. So yeah, so far so good. Now we get to the benchmarks, right? So with our new data frame, we want to check the is default. And then let me just do a quick plot there so that you can see that these are the people that did not default. These are the people that defaulted. So percentage wise, what does this mean, right? So it means your defaulters are 12% of your data set, and the people that did not default are 88%, meaning that if I was told to predict whether a person would default or not purely by guessing, I would always pick default because I have 88% chances of being correct all the time, which you would learn most of the time. That's what your model does. So any model that you build has to be greater, the accuracy has to be higher than 88%. Otherwise, random guessing will work just as well. To demonstrate or to test this theory, so what I did was I said, since because my test data has 905 entries, right, 905 people that I have to predict whether they will default or not. So I built a loop, a function to say that from 1 until 905, so Python does not include the last value, so it's 906. So it's going to count from 1 until 905. So every time it does the count, it will add a 0 into this empty set, right? So let me check my sample head. So now you have the transaction ID is defaulted. Let's check the length of my empty set. It's filled with zeros, right? Let me just do this real quick. I just wanna print out the first 5 elements. You can see it's zeros all the way to 905, right? So now what I'm doing right now is creating a data frame that would have the customer IDs from the test data, and its defaulted is going to be the dummy results that I just created here, right? And let me do this. Let me pull up the head for the dummy submit head. So yeah, you can see this is going to be my sample submission. I'm going to submit this first. Its default is basically zeros from the first entry to the last one. I just want to test whether 88% of the time will I be correct. So if theory works out, I should get, the assumption here is that your training data has the same distributions of defaults and non-defaulters as your test data, right? So now I'm gonna create the data frame, and then I'm gonna export this data to a CSV called benchmark. And now I'm gonna go to Zindi. Let me just go to the top and open that challenge real quick. Let me scroll back to where I was at benchmarking. Right, I was right here. So I saved the file as benchmark. Right, so I'm gonna submit. All right, like I mentioned, so yeah, so I got only 50% correct. So this indicates that my assumptions were off. So your testing data does not have the same distribution as your training data for the defaulters compared to non-defaulters. So now this we have to build a machine learning model because we have tested the naive approach. It did not work. So right, I'm gonna start off by checking out the missing data on my test data. So I can see that issued date loan and loan ID and yeah, investor world loan application. So these ones I did not have them in in my okay, so the variables that I'm missing, your loan application ID, I do not have them in the test training data set, right? So I'm gonna ignore those ones. Yeah, I'm gonna go ahead and then check out the head of the data set. Then test dot third party ID. So yeah, so from the previous data set, we also included whether it was confirmed that the third party was used, and we don't have this one in the data set, but we have third party ID, right, in the test data set. And when there's no third party ID, I mean, we can assume that then there's no third party. I tried doing this a different ways, by saying that, hey, if it's an N, just give me a 0. If it's not, give me a 1. So they gave me a lot of issues. So the approach that then I took was that I'm going to convert all of these things to strings, right? So once they are strings, nan is a nan. It's no longer a special character in Python. So and then I'm going to write the function that says that, hey, if my entry is equals to nan, which is a string, just give me a 0. Otherwise, just give me a 1. Right, and so this is why I convert all the inputs to strings, and then this is why I apply my confirm function, and I create this third party confirmed in a test data set, and then I do a count, and then I see that 478 means that there were third parties, and then 427 there were no third parties, right? So now that I have my training data set, my testing data set, I will apply the same transformations that applied on a training data set. First of all, I'm going to convert the date times from objects to date times. I'm going to extract the start and the end, months, years, and dates. And then I'm going to call head of my data set. So now you can see that I've represented this data in this format. I no longer need it. I dropped it. I am going to standardize with the same numbers that I did in my training data set. And now I have my full data set here, right? So now we get to the interesting bits. So for me, when I build machine learning models, I always start with either random forest or XGBoost, because those ones generally are the best ones. So if there's no other model that can top their accuracy, then that's the model. Otherwise, I will take the next one that has a better accuracy than this one. So I'm going to be using XGBoost. We can search the documentation for the information. There's a lot of information on scikit-learn about XGBoost. So yeah, the arguments that I inputted here, the max depth of 6 and the number of estimators of 500. Generally, after doing my hyperparameter tunings, those are the ones that I get. You know, my maximum depth is normally around 5 and 7. So I went with the 6, and the number of estimators, they range from 400 to all the way to 700. So I'm comfortable at a 5, right? I did not do hyperparameter tuning for this model, so those numbers are just, you know, from experience. So yeah, I'm gonna call my model, right? I'm gonna instantiate the model there. Then I'm gonna get the head off of my training data set so that I can define my training, my X train. So I'm going to select everything besides its default, right? Its default is my target variable. Everything else is an X. So Y train will be its default. That's what I'm doing there. Now for my X test, let me pull down the heading of X. So you can see here, everything matches up, lines up perfectly, except for its default. Because its default is in a training dataset, we want to predict it for the testing dataset. So I'm going to say X test is equals to test data frame everything. Here I'm gonna train my model. It's gonna take a few seconds. There you go. So the model is built, and it will show you like your default parameters and the ones that I've inputted. And now I'm gonna run predictions. So I'm gonna say model.predict, and then I'm gonna say results, build a dictionary, input everything in there, and then save the results as XGB results. Okay, cool. So after exporting the results, I'm gonna head on to Zindi, drop a new submission called XGB results, and submit and see how my model did. The funny thing is the model did way worse than random guessing. That is interesting. I did not expect that, by the way. Okay, cool. So let's head on to the bonus section. So yeah, the bonus section. It's just a list of things to explore to improve the accuracy of the model, right? So your product categories, you can use one hot encoding for that, and then you would have more features. And you can use transaction IDs to extract more information from those two files, put it in your trading data set, and then you would have more training data. Actually, the 49% accuracy for this model, it kind of makes sense, because if you think about it, we just took the money that was borrowed, the date the money was borrowed, and when was the money due. That is not really indicative of whether a person would default or not, right? So yeah, the third thing that you can try is not dropping the nans, right? Skipping the step where I drop the nans on the the training part of the tutorial, right? And then you can also try to balance your classes, because you have 12% defaulters and then 88% non-defaulters. So what your model generally does is, let me learn the 88%, because 88% of the time I'll be correct, right? And you don't want that. You want to know when people will default rather than when they will not default, because that means more to you, or rather the customer, than telling me that, hey, that guy's not going to default. That does not add value, right? So when you tell me that, okay, this person will default, that adds value to me as a credit provider, because then what I can do is offer that person lower credit than I originally would have offered them, because they have a higher risk of defaulting. And then the last stage, which is the one that I'm going to try, is AutoML. I'm going to use automatic machine learning to build a model that would have a better accuracy with more data. So here I just wanted to demonstrate the process of getting data from Zindi, doing your EDAs, doing your feature selections, doing your machine learning training, exporting that data, and then submitting it to Zindi. And then, just to get you familiarized with like the platform, how it works, and all those stuff. So yeah, man, I would like you guys to try this challenge, make your submissions, and then come back and comment on the video how accurate your model was. Try a different model, try random forest, try cat boost, try neural nets, just go crazy, and then just let me know what accuracies you guys get. Cheers.